All right, hey team. In this video, hey physicists, we are going to be practicing a problem that we've done the last couple days. What do you do when you have forces in equilibrium? In other words, the forces are all balanced and the object's not moving. So a very simple example would be a sign, say hanging from a rope, from two ropes, and we know the angle of the ropes is 30 degrees, and we know the tension in each of these is 50 newtons. Okay, so pretty straightforward. This rope has 50 newtons of force in it. This rope has 50 newtons of force in it. And the question that I might ask is, what is the weight of the sign? Okay, so to do this, we need to figure out what is FTY for both of these ropes and add them together, right? Because each rope is pulling up a little bit to keep the sign from falling. If I take the amount that this rope's pulling up and add it to the amount that this rope's pulling up, guess what? We got the weight, so we can find the answer. So how do we do this? Well, first thing we're going to do is decompose these vectors. So I'm gonna find what I'll call ft1x, and then ft1y. I forgot to draw the tip on this resultant vector. I'm going to draw the tip on this resultant vector, so it looks like that. And we can do the same thing on this side. So ft2x and ft2y. Now remember, because the sign's not moving, what we can say is the sum of the forces in the y direction is equal to ft1y plus ft2y plus fg, and they must be balanced, so they equal 0. And then in the x direction, we can say fx equals ft1x plus ft2x must equal 0. Okay? Since we're interested in fg, we just need to find ft1y, and then we will know what fg is. So how am I going to do that? Well, if I have this triangle here, I'm going to make it a little bit bigger down here. We've got 50 Newton force in the rope. We've got an angle of 30 degrees. This is my ft1 in the x direction, and this will be my ft1 in the y direction. So if we look at this triangle, this is the opposite side, this is the adjacent side, and this is the hypotenuse. So because I have the hypotenuse and I want to find O and A, sine and cosine will work for me. Sine will give me the opposite side, so sine of O, which is this, so sine of 30 equals O over H. O is this, so ft1y over hypotenuse, which is 50. Sine of 30, make sure your calculator is in degrees, is 0.5. So you're going to take 0.5 times 50. So ft1y equals 25 newtons. And then similarly, to find ft1x, or this vector here, we're going to do cosine of 30 equals the adjacent side, which is this ft1x over 50. And when we do that, we get ft1x equals 43.3 newtons. Now, we have our ft1y, and since these angles are the same, this is the only case where this is true, when the angles are the same. If the angles are different, this would not work. I know that ft1y, which is 25, must be the same as ft2y. So these are both 25 newtons. So then I ask you, physicist, if both ropes are pulling up with 25 newtons of force, what's the weight of the object? And what you should see is that fg is equal to 50 newtons. So that's how you do a static equilibrium problem. This is called static equilibrium. And this is what we'll be working on today, and we'll get ready for our test on next Tuesday and Wednesday.